Welcome to our lesson on harmonic progression. In mathematics, a harmonic progression is a sequence of numbers where the reciprocals of the terms form an arithmetic progression. Let's understand what that means and explore some examples. Let's first recall what an arithmetic progression is. In an arithmetic progression, each term differs from the previous term by a constant value called the common difference. For example, in the sequence 3, 7, 11, 15, each term differs by 4 from the previous term. So the common difference is 4. The general form of an arithmetic progression is a plus d, a plus 2d, and so on, whereas the first term and d is the common difference. Now, a harmonic progression is defined as a sequence where the reciprocals of the terms form an arithmetic progression. So if we have a harmonic progression h underscore 1, h underscore 2, h underscore 3, and so on, then 1 over h underscore 1, 1 over h underscore 2, 1 over h underscore 3, and so on must form an arithmetic progression. Let's look at a simple example. The sequence 1, 1/2, 1/3, 1/4, 1/5. The reciprocals of these terms are 1, 2, 3, 4, 5, which is clearly an arithmetic progression with first term 1 and common difference 1. Let's derive the general formula for a harmonic progression. If we have an arithmetic progression, a plus d, a plus 2d, and so on, then the corresponding harmonic progression would be 1 over a plus d, 1 over a plus 2d, and so on. So the nth term of a harmonic progression can be written as 1 over a plus n minus 1 times d, where a is the first term of the corresponding arithmetic progression, and d is its common difference. A very common and important harmonic progression is the one where the corresponding arithmetic progression has a first term of 1 and a common difference of 1. This gives us the harmonic sequence 1, 1/2, 1/3, 1/4, and so on. Here, the nth term is simply 1/n. When we add up the terms of this harmonic progression, we get what's called the harmonic series, 1 plus 1/2 plus 1/3 plus 1/4, and so on. Interestingly, this series diverges, meaning that as we add more and more terms, the sum keeps growing without bound, even though the terms get smaller and smaller. An important concept related to harmonic progressions is the harmonic mean. The harmonic mean of n numbers a underscore 1, a underscore 2, up to a underscore n is defined as n divided by the sum of the reciprocals of all the numbers. Mathematically, this can be written as h equals n divided by 1 over a underscore 1 plus 1 over a underscore 2 plus 1 over a underscore. For example, let's calculate the harmonic mean of 4, 5, and 20. We get h equals 3 divided by 1/4 plus 1/5 plus 1/20th, which equals 3 divided by 5 plus 4 plus 1 over 20, which equals 3 divided by 10 over 20, which equals 3 times 20 over 10, which equals 6. Let's look at another interesting property of harmonic progressions. If three numbers a, b, and c form a harmonic progression, then b is the harmonic mean of a and c. To verify this, if a, b, c form an HP, then 1/a, 1/b, 1/c form an AP. This means 1/b minus 1/a equals 1/c minus 1/b. Solving this, we get b equals 2ac divided by a plus c, which is the harmonic mean of a and c. This relates to a broader relationship between the arithmetic mean, geometric mean, and harmonic mean of two positive numbers a and c. The arithmetic mean is a plus c over 2, the geometric mean is the square root of a times c, and the harmonic mean is 2ac over a plus c. And they follow this inequality. Arithmetic mean greater than or equal to geometric mean greater than or equal to harmonic mean, with equality if and only if it equals c. Finally, let's briefly discuss some applications of harmonic progressions. One application is in electrical engineering, where resistors connected in parallel follow a harmonic relationship. The effective resistance R is given by 1 over R equals 1 over R underscore 1 plus 1 over R underscore 2 plus so on. In optics, when working with lenses and mirrors, the relationship between object distance, image distance, and focal length follows a harmonic pattern. Another practical application is in work rate problems. If person A can complete a job in a time t underscore a and person B in time t underscore b, then working together, they can complete the job in time t, where 1 over t equals 1 over t underscore a plus 1 over t underscore b. In conclusion, harmonic progressions may seem abstract, but they have many practical applications in various fields of science and engineering. To summarize what we've learned, a harmonic progression is a sequence where the reciprocals form an arithmetic progression. The nth term of a harmonic progression is 1 over a plus n minus 1 times d. The harmonic mean of two numbers a and c is 2ac over a plus c. And harmonic progressions appear in many practical applications, from electrical circuits to optics and work rate problems. Thank you for watching. I hope this helped you understand harmonic progressions better.